Let's look again at the example where we were comparing the time that it takes for fading to occur with two different brands of outdoor paint. We want to come up with an effective way to reliably describe how spread out the data values are, how much variation occurs in the data set. So we'll begin by ordering the data values 10, 20, 30, 40, 50, 60, and then finding what are called the deviations from the mean by subtracting the mean from each data value. So we'll subtract 35 from each of these data values. 10 minus 35 is negative 25. 20 minus 35 is negative 15. And we'll continue to fill in this column. Now, it would be nice if we could find an average of these deviations from the mean, but the problem is that if we add these values, these deviations, we would wind up with 0, which is not surprising since the mean is a balance point for the actual data values in a data set. So what we'll do is we will square each of these deviations from the mean. Now we can find the sum for these squared deviations from the mean just by adding these values, and we would wind up with 1,750. Now we can use these calculations to find what is called the population variance. The population variance is the average of the squares of the distance each value is from the mean. The symbol for the population variance is sigma squared. This symbol is the Greek lowercase letter sigma. The formula for the population variance is to take the sum that we just found, the sum of the square deviations from the mean, and divide it by the size of the population. We have 6 data values, so our sum, 1,750, will be divided by 6. The variance will be 291.7 when we round to 1 decimal place. The population standard deviation is the square root of the variance. The symbol for the population standard deviation is sigma. So what we can see is that we will take this value that we found for the variance and we'll find the square root, and that is what we will call the standard deviation. So the standard deviation will be the square root of the variance. When we take the square root of the variance, we find the standard deviation to be 17.1. Now let's do the same for brand B. Let's first find the deviations from the mean and then square them. And now again, we will sum the squared deviations from the mean, and we'll find that sum to be 250. This time, our variance then will be 250 divided by 6, and we will wind up with a value of 41.7. Then finding the standard deviation by taking the square root of the variance, we find a standard deviation of 6.5. Again, it is important that we observe the general rounding rule, which is that we should not round at all until the final calculation has been made. The rounding rule for the standard deviation is the same as the mean. We should round it to 1 more decimal place than occurs in the raw data. So now let's look again at the variance and standard deviation for each of these data sets. The variance for group A was 291.7 and the standard deviation is 17.1. The variance for brand B is 41.7 and the standard deviation is 6.5. And looking at the distribution of these data sets, we see that it is not surprising at all that the standard deviation and the variance for group B should be less than the standard deviation and the variance for group A.